This video will cover aspects of Lab 2, faults and folds, the first section coming from the Lab 2 work for the LifEarth class at Midwestern State University. I'm Dr. Jonathan Price. The first part of this video will illustrate how you can cut out each of the fold models, starting with the normal fault block. We'll speed this up a bit, but essentially you want to cut along the solid lines on the outside so that each of the edges and tabs are exposed for easy assembly. When we're complete, we'll have a three-dimensional model of a rather simple normal fault that you can then examine. Just finishing up here, now we have a completely cut out model. We'll start the folding process. Probably easiest to start with folding the sides. And of course, the sides of this model have the beautiful offset arrows. Essentially, we'll want to fold all the tabs over as well, and then fold each of the panels of the model. So that we can make the box-like enclosure. You'll find that the fault models are a little more difficult to assemble than the fold models in this exercise. And you may find that you've folded one of the panels the wrong way, but just start to put it together and you can see that you need to enclose the box so that all of the planes are properly folded together. The completed model allows you to see the fault from the underside and the side views and the top view. The first problem asks us to look at our completed model and imagine that the fault has not offset the stippled bed. So we're going to need to draw this reconstituted in its original format, essentially the stippled layer as an uninterrupted layer across the entire model. next part of the exercise asks us to identify and label the hanging wall and foot wall. So I'm going to draw a little stick figure on top of the fault, and where the stick figure's feet fall, that is the foot wall, and the hanging wall is over his shoulder. By extension, that then continues onto the top part of the model. So the foot wall doesn't change just because we're away from the side. That also is the foot wall there, and the hanging wall. And then on the other side, we don't even have to draw another stick man again, because it continues on. Foot wall and hanging wall. And finally, we can answer questions about the offset with the model as well. So looking at that change in vertical distance between the bottom of the gray line on the foot wall and the bottom of the gray line, the stippled line on the hanging wall. And then I can complete a triangle which shows the horizontal offset and then measure them in millimeters. And there we have measurements for both the vertical and horizontal offset in millimeters. Don't forget the units. And lastly, just a quick show off of an assembled strike slip model. I think you'll find the reverse fault model very similar to the normal fault model. And again, the fold models are a little more straightforward. We can use this to measure the offset and answer a question.